Okay, we're going to go over domain and range, and specifically of quadratics. What we got to get used to is first domain and range of a continuous function. A continuous function is anything on a graph that essentially has a line connecting it. It could do that, it could go like this, it could go like this, it could like do this, whatever, one of those silly things. It's continuous, right? So if it's continuous, we essentially start our domain, and domain deals with the x values. So if we're on a graph, here's your x, so that's your domain, and here's your y, that'll be your range, okay? Your domain, if it's a continuous function, like we said, maybe it does that, we're going to start it with x e r. Right? What that means, x is the element of all real numbers, so it's every possible decimal because it's connected. And then we would talk about if there's any restrictions. So we'll kind of use this idea, is there restrictions to x? Sometimes there's not. So if there is no restriction, we just kind of end it there. X is every real number. And this is technically an example of one. This, what I've drawn here, it goes left and right forever. Okay, but if it stopped here or something, we would have some restrictions. X is less than and equal to or greater than, all these silly numbers. We would add stuff to that, okay? The same idea happens for range. If it's continuous, we start y, e, r. Y is every real numbers. And this line means such that, so if there's restrictions, and again, if there's no restrictions, it goes up and down forever, then we just end it there. If it doesn't, we got to put it, y is less than or and greater than or less than and equal to and some numbers, and then we end it there. Okay, but let's talk about a quadratic, because quadratics have something pretty specific to them. So we're going to bring up an example where we have to plot some stuff. So here are some dots, okay, and I'm going to do my best to follow them. 0 and 10, 1 and 4. So we're going to kind of connect these. Oh, it's supposed to go up to 80, but I guess we can't quite see it. And as I connect these, we kind of get the feeling, I think this is supposed to be like way up there. It's supposed to take off and do that, okay? And then it probably does the same thing in the other direction, though they weren't written out. This is the general idea of it, okay? What's important here is I want you to realize that there's almost like an imaginary line here, okay, at the bottom. And our parabola doesn't go below that. It goes up forever, according to these arrows. And though it's hard to see because it's going up, it'll technically go left and right forever too. Okay, so that's going to have pretty big implications for us. First of all, that really means for our domain, okay, we're going to have x, e, r. Okay, and I put those silly brackets around it. Oops, that should go here. I don't know how to erase specifically. And our range, well, it's continuous, so our range will have y, e, r, but there are restrictions, okay? And we have to figure out what the lowest point is. And by looking at this, it's kind of hard to see, but luckily, I'll turn this off, I actually built the equation of this. Okay, so my drawing wasn't perfect, and we'll kind of delete my drawing. But this is it here, okay? This is the equation of that. So by the equation, I know what my lowest point is going to be. Because it's the vertex k value is 2, so that means this is the value of 2. That's its lowest point. There's like an imaginary line at 2 cutting it off. So we know that the range, okay, is yer, because it's continuous, such that y is greater than and equal to, because it technically touches, the value of positive 2. Okay? And the domain, we already said, is, do you remember?
Oh, XER.
That's it, X-E-R. And as long as it's a normal parabola, okay, and they haven't like drawn a picture and cut something here and cut something here, as long as it's just normal and it goes this way forever, your domain is always going to be XER. And your range is always going to be YER, with Y being greater than, or if it was negative, so the parabola is going the other way, y is less than or equal to, for instance, the value of 2. All of ours will be written this way, okay? So let's kind of get rid of those. So for instance, I'll write the same, whoops, delete that, go away. Okay, if I were to write negative 2 x minus 2 of 2 plus 2, I did a lot of 2's there, and let's zoom out. And look at that. Same value, just going the other way, so it's less than and equal to. So I'll quickly write it again here. In our version, it was just XER. And our other one, it was y is greater than or equal to the value of 2. And then it ends there. Okay?